Hello students. Now in this video we are going to see another non-parametric test. Okay, this is also another non-parametric test. It is Wilcoxon's signed rank sum test. Okay, now in the previous one we had seen my Man-Whitney test, Man-Whitney U test, and in that case we had compared two samples. Okay, and those two samples were independent of each other. Okay, now in this Wilcoxon signed rank sum test, my samples will be dependent on each other or they will be paired. Better word is a paired samples. Okay, so again, paired, that means what? The number of or the size sample of both the data will be n1 and n2 will be equal. Okay, now how to proceed with this, we'll see with an example. Okay, most of the example will be same, that is writing the null hypothesis h naught based on the question, then it will be writing h1. Okay, then setting up of level of significance and then some test statistics. Okay, so let's see how to proceed with this in this example. Now see, it is saying generally it is claimed that there is more effect of remembering by visuals than by audio. Use Wilcoxon's test to test this hypothesis. Okay, so now what this states is that there are two datas are given. One is remembering by visuals and another is the remembering by audios. And now I need to compare them. Compare these two datas. And if we see, the number of observations are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 observations are there in both. It is a kind of paired data. So I can treat these visuals as my X and these are my as my audios by my Y. Okay, now first thing is that what it is asking, that there is more, that the claim is what, there is more effect of remembering by visuals than by audio. Now more effect of remembering by visuals than by audio, this should be my hypothesis. Now my null hypothesis, I cannot write this as there is more effect. My null hypothesis will be always what, they both the things are equal. Okay, so that is what, there is no difference between the two. Okay, so how will be my h naught in this case? See, h naught will be something like, I'll write it here. H naught will be, there is no significant difference in remembering by visuals or audio. Sorry, visuals and audios. Okay, and h1 will be this hypothesis that there is more effect of visuals than by audio. Okay, I can say this is my one tailed, okay, or a single tailed hypothesis, that it is visual is greater than the audio, the effect of visuals in remembering is greater than the audio. Okay, okay, so this is how the things have been. Now once h naught and h1 has been set, now again the in this question level of significance has not been mentioned. It will be, I will take it as 5% or 1%. Okay, I will test at both. Now how to proceed with this is, now these two paired data are given. What I will do is, I will find out the difference between the two. Okay. Now difference in the sense d, that will be given by x minus y. Okay. Even if you do y minus x, it is one and the same. Nothing is going to change. Okay. But I will just take it x minus y, one and the same. X minus y minus x. Finally, you will get the same answer. Okay. So now 20 minus 19, that comes out to be 1. 17 minus 16 comes out to be 1. 14 minus 15, it's minus 1. 18 minus 16 2, 15 minus 13 2, 16 minus 16 is 0. So now it is 0, therefore I will just put a equal to sign. Okay, I won't be considering this number anymore. Okay, that there is no difference, no, that is what my h naught is being satisfied. Okay, there is no significant difference in remembering by visuals and audios. Okay, so I won't considering this. Now 19 minus 15 is 4, 16 minus 18 is minus 2, 17 minus 14 is 3, 18 minus 17 is 1. Okay, so all these differences I will write down here along with their signs properly. Okay, and whenever it is equal, I will just put a equal to. So whenever my difference is coming to 0, I will just put an equal to sign. Okay, so now this differences has been calculated. Next thing is calculating their ranks or allotting the ranks to them. Now, while allotting the ranks, what I will do is I will ignore the signs of them. That is, negative or positive doesn't matter. Okay, so I will allot the ranks in the increasing order. Now, in the increasing order, that means what? This minus 1 will be also considered as 1, and this one. Okay, so I will just ignore their negative signs and I will allot the ranks to the absolute values. Okay, so now first, for at the first rank there are this 1 1 1 and 1. There are four ones together. So if I'm arranging them in the ascending order as we have done in the man Whitney test, what it will be, writing this as 1 1 1 1. Okay, so that is what all these four values will have same rank. Okay, now we had seen that when the same rank, when there is a tie for the ranks, how we calculate the ranks, we allot a same rank to all of them and that rank is the average. So it will be what, this is the first rank, second rank, third rank, fourth rank, then the average of them, that is 1 plus 2 plus 3 plus 4 divided by 4, that is the mean value of those ranks. Okay, so it will come out to be 1 plus 2 3 3 3 6 6 plus 4 10 10 by 4, that is 2.5. Okay, so this value comes out to be 2.5, that is the average of them. Therefore I will allot the ranks 2.5, then this one will have also 2.5, this one will also have 2.5, and again this last one will also have value 2.5. Okay, now after one, these ones have been allotted, now the next is 2. So these two, 2 and this 2, this minus 2 will be also considered. So basically there are three twos with me. Okay, now what will be the ranks of them? Total 4 ranks have been allotted already, so their ranks are starting from 5, 6 and 7. Now, when that is, there is a tie for the ranks. Okay, and when there is a tie, how we calculate? We take the average of them. So 5 plus 6 plus 7 divided by how many repetitions? 3. Therefore, 3. So, and this 5 plus 6 plus 7, that comes out to be 18 by 3, that is 6. Okay, so these ranks will be 6, 6, and this one will also have 6. Okay, now when this is equal to sign, no rank will be allotted to that. Okay, so it's a dash again. Okay, so after 2, next number is 3. So 3, it will have what, till 7 the ranks have been allotted already. So 3 is will have my rank 8. Then after that the last number will have my rank 9. Okay, so this is how the ranks have been allotted. Please keep this mind that if there is a tie between the numbers for the ranks, then they have to be given the average rank of this. Okay. Okay. So now this has been done. Now, what I will do is I will write my revised n. My n value was what? Old n value was 10, that is number of observations are 10 here. Okay, now I will write my revised n in the sense it will be what, 10 minus whatever those numbers which have been having the value or the difference as 0 will be subtracted. That is what I will ignore this point. Okay, apart from this, what I will use? All the other ones. So how many terms are there with the difference 0 or with an equal to sign? There is only one, so I will subtract that. So it will be what? 10 minus 1, that is only 9. So basically I'll be dealing with only 9 items here. Okay, that is the reason I have revised my n to 9. Okay, and this n, or if you want, I will just for simplicity write this as n dash. Okay, many books write it as just revised n. Okay, so I will be using this n or this n dash henceforth. Okay, so now next step is, once I have calculated n dash, next step is calculating t minus and t plus. Now t minus is something like, let's see how many differences in this third column are negative. How many are there negative? This one and this one, that is minus 1 and minus 2. I will look for the ranks of them. That is minus 1 is having a rank 2.5, minus 2 is having a rank 6. Okay, so this t minus will be the sum of these two. Okay, so t minus is the sum of ranks of negative differences. Okay, so it will be in this case what? Two negative numbers, that is minus 1 and minus 2, and their sum ranks, that is 2.5 plus this 6. So it will come to 2.5 plus 6, and that comes out to be 8.5. Now you know what will be t plus? T plus is the sum of ranks of positive differences. Okay, so now all the rest, that is 2.5 plus this 2.5 plus 6 plus 6 plus 9 plus 8 plus 2.5, all this will have these values. Okay, so 2.5 plus 2.5 plus 6 plus 6 plus 9 plus 8 plus 2.5, and this value comes out to be 36.5. Okay, so t minus and t plus have been calculated. Now next step is calculating t, and t is given by minimum of t minus and t plus. So what will be the minimum? Minimum of this will be, t minus is what? 8.5, t plus is 36.5. So the minimum value or the smallest value is the 8.5. So I have my t. Okay, now once this t has been calculated, next step is writing the test statistic z. Okay, now in this case, again similar to the Mann-Whitney test, the test statistic is defined by, now in place of u it is t here, minus mean divided by the standard deviation. Okay, and again a positive value of that will be considered. Now t is the value which we have calculated already, that is the minimum of the tx and ty's. Okay, now how to calculate mean? Now again the formula for the mean changes, mean and the standard deviation formula changes in this case. Okay, so for the Mann-Whitney test, the mean value was given by n1 into n2 by 2. Okay, but in this case, for this Wilcoxon's test, the mean value is given by n into n plus 1 divided by 4. Okay, okay, and let me be clear, this n is the new, my revised n, so I will just write this as n dash. N dash into n dash plus 1 upon 4. So similarly my standard deviation is given by root of n dash up into n dash plus 1 to 2 n dash plus 1 divided by 24. Okay, so if I want need to calculate this mean, This mean will be in this case n dash. N dash is my 9. Okay. So 9 into 9 plus 1 divided by 4. This comes out to be 22.5. Okay. And my standard deviation will be, again in this case, don't get confused how this 24 has come. This is a part of the formula. Okay. So my standard deviation will be n dash, that is 9 into 9 plus 1 into 18 plus 1, that is 19. So this comes out to be, standard deviation comes out to be 8.44. Okay. Now what I will do is I will substitute these values in this test statistics. So my test statistic will look like z is equals to mod of t value I have calculated to be 8.5. My mean value is 22.5 divided by a standard deviation value, that is 8.44. Okay. Now this statistics, if you solve this, it comes out to be 1.66. Okay. Now this is my calculated value. Now if you check for this at 5% level of significance, okay, it will be, the critical value will be 1.96. Okay. Now this 1.66 is less than 1.96. Therefore, my H naught is accepted. Now, okay, and at 1%, the critical value is 2.58. Okay, again, this 1.66 is less than 2.58. Therefore, this H naught is accepted at 1%. 1% level of significance. And similarly, this is accepted at 5% level of significance. Okay, so my conclusion is what? H naught. What was my H naught? There is no significant difference in remembrance by visuals and audios. Okay, so this statement is being accepted. Okay, so this is how you solve by Wilcoxon's signed rank sum test. Okay, so I'll just give a quick review of this. Now, for this Wilcoxon test, signed rank sum test, what you will do when two datas are given, they will be given in pairs. Okay, you will calculate the difference of the two. D is equals to x minus y or y minus x, one and the same. Okay, and then you will ignore their ranks and you will allot the values. You will ignore their signs and you will allot the ranks to them in the increasing order. Okay, and whenever the difference between the two values is 0, you will not allot any rank to it. Okay, and that value will be discarded. Okay, and once this has been done, all your h naught, h1s and level of significance has been set, you will write some revised n dash. Revised n dash will be total number of observations minus those values which have got ranks. Okay, or those values whose difference is not 0. Okay, so from that you will get n dash value. Then you will calculate t minus and t plus, where t minus is the sum of the ranks of negative differences, t plus is the sum of the ranks of the positive differences. Then you will calculate the t value, that is the minimum of both this t minus and t plus. Next is what? Next step is calculating the test statistic. Test statistic will be given by z is equals to t minus mean divided by the standard deviation. Now in this case, mean is defined by n dash into n dash plus 1 upon 4 and standard deviation is defined by root of n dash into n dash plus 1 up into 2 n dash plus 1 divided by 24. Okay, and once this value has been calculated, this calculated z value will be compared with the critical values at 5% or 1%, and then based on that your h naught or the null hypothesis will be accepted or rejected, that will be concluded. Okay, so this is how we proceed with this kind of test. Now there can be another twist in the story, is that now in this question, this visuals x and audio y, that is x and y data was given. Now it can also happen that in the exam directly this third column will be given. Okay, that this difference column will be given and you will have to allot the ranks directly. So what you will not have to use anywhere this x and y column. So even if you check in now, nowhere you have used the values of x and y except for calculating these differences. Okay, so if directly this difference table is given, it is easy to calculate the ranks. I mean, it is easy to allot the ranks and all. Okay, and proceed further. Okay, so that can be also the thing that it can be given directly. Okay, so thank you.